Hello class, this is the assignment for your Unit 7 Stoichiometry for 8 April 2020. I'm going to walk you through two calculations today. But first of all, we have some announcements we've got to make. We're going to be starting your graded exercises soon. As soon as the county lets us know, we're going to get started with those. I'll give you a couple of days to get ready. But what I plan on doing is your exercises are going to have to be due at 3:40 the day that they are assigned. I always give you your assignment the night before, so you have all kinds of time to get it finished. You're supposed to be in class from 8:30 to 3:40 each day doing this work, not waiting until 10 o'clock at night to get started. So if you want to do that, go ahead and you'll suffer. If it's submitted by 3:40, you'll get 100. If it's from 3:40, after 3:40, and before 11, about 11:59 that night, it will be a 75. If you submit it the next day after midnight, it'll be a 0. These are all have to be approved. It's going to be whatever the district tells us to do. As long as they don't do that, if they leave it up to us, that's what I'm going to do, because I'm tired of people starting their work at 10 o'clock, submitting things late, a day late, 17 hours late, and things like that. That's ridiculous stuff. The schedule for testing, those will be Monday through Thursday. Wednesday will be a kind of a special day. You'll be having some type of lab activity. You might have to do a little bit of research on your own about some type of lab and submit some type of an essay or something, but I'll give you some more information about that. On Fridays, though, is going to be your test, and it's going to be a 30-minute test, so it won't be long, but it'll be something you have to get done. I'm telling you right now, those are your periods. The first period is from 9 to 9:30, so your test starts at 9. You must have it submitted by 9:30. If it's not submitted by 9:30, I'm not taking it. So if you want to complain about it, so go ahead and complain. You need to get it done and submitted by 9:30. Second period, you get it start at 10. It'll be open for you to do at 10. It has to be submitted by 10:30. And in fourth period, you have until 12 o'clock, until 12:30 to submit it. Any late submissions, I'm not going to take. Okay, I'm going to have the video listed there in a while for you. I'm going to work two problems for you. I don't know which ones. Let's do number 8 will be good. Let's do that one. So make sure you pay attention here. Let me cut and paste some of this stuff here to make it easier for me and you. First thing you should always do when you're doing these calculations is you actually write down this little formula. It always helps out. The grams of your known converted to the moles of your known, converted to the moles of your unknown, converted to the grams of your unknown. For this problem, though, it tells you have, well, I've got to put that up there. Oops. Cut. Let's put that up there out of the way. And paste. There you go. Okay, for here, the grams of the unknown is 98. You have 98 grams of P4. And I'm going to have to also lower font this so I have room for it. Okay, you have 98 grams is given of the P4, and you're looking for how many grams of O2. So the first thing you have to do is you take your molar mass of the 4 phosphorus. You look for the phosphorus on your reference table. So you have to find the atomic mass of 1 phosphorus, which is 30.97. 30.97. Multiply that by 4. 30.97. 3.97 times 4 equals 12388. 123.8888. That is grams per mole. That's how many grams is in 1 mole of P4. Okay. So then you're going to try to find out how many moles you have. Well, you have to take the given and divide that by the molar mass. So for here we have the given is 98. We were given 98. So you take the 98 divided by the molar mass of 12388.88. That gives you the number of moles of your known. 98 divided by 123.88 equals, let me do it again, sorry, 98 divided by 123.88 equals 0.791. 0.791. Always round as you go to 3 decimal points, because if you're not, everybody's going to have different numbers. So let's all do the same thing, okay? Put an asterisk there to show what that was. Now you're trying to convert, so you've already gone from the grams to the moles, not from the moles of the known. Now you got to go to the moles of your unknown. If you don't remember how to do that, you take your moles of known, times it by the coefficient of unknown, divided by the coefficient of the known. So this time you're going to be taking your moles of your known is 0.791. You multiply it by the coefficient of your unknown. So this time you're looking for oxygen gas. That's 5. Your known is 1, so you multiply it by 5 over 1 to come up with the amount of moles that you have of your unknown. 0.791 times 5 equals 3.955. 3.955. So there's your number of moles of your unknown. 3.955. Now what you need to do is we've gone from the grams of the known to the moles of the known, from the moles of the unknown. Now you got to find how many grams is in 3.955 moles of oxygen gas. We should know that oxygen gas is 2, and I'm not going to fool with that anymore. I'm tired of fooling with that. That's 32.00 grams per mole, right? So we know it's 32 grams per mole. So all you have to do on this, let me go back and do it as small anyway so I can get some more room here. Then what you need to do is you take your moles of unknown, times it by the molar mass of the unknown. This will give you the number of grams equals number of grams of unknown. And that's what you're looking for. So you have all the information you need right now to do the calculation. So you take the moles of the unknown, which is 3.955, 3.9555 times your molar mass of your unknown, which we already did, 32, times 32. This gives you the number of moles of your unknown. And that's number of grams of your unknown. 126.56 grams of oxygen gas. That's what you're looking for. It's because you're looking for that. It says your unknown is grams. You're trying to find the grams of oxygen gas. You just calculated. There's your answer. So let's do another one. Let's do number 10. So I'm going to have some space over here, okay? Let's take that formula again. We will copy and paste it down. Paste. Oops. Paste. Okay, I don't know what I did here. I must need to make it smaller again. Okay, the grams of the known. So you have grams of the known, moles of the known, moles of the unknown, and grams of the unknown. Let me get rid of that line so it won't be in the way. So now you go back and you go to the grams of the unknown. It says 444 grams of Br2, and you're looking for how many grams of aluminum. So you take Br2, you multiply it by the atomic mass to find out the total mass, the molar mass rather. So you take 79.9 times 2. 79.9 times 2 is 159.8. 0.80 is grams per mole. In other words, in every mole of Br2, there is 159.8 grams. So we did this already. So now you know the moles of your known is 159.80. Now you're trying to find, go back to here. Let's see if I can print this out. Copy, and I'll paste it down here somewhere so we won't have to worry about it like we did last time. So you take your moles of your unknown. Well, first of all, you got to come up with your moles. We don't know that yet. You got to take your given divided by the molar mass. The given is 444 rather, divided by 159.80. Let's get rid of this. That was incorrect. That comes up with a number of moles that you have. So you take your 444 divided by 159.8. That gives you 2.778 moles. So you have 2.778 moles of your known. The way you come up with your moles of your unknown is you take the moles of your, that's not the right formula. Take this one here, moles of the known times the coefficients. Copy. And sorry about that. Paste. The moles of your known, we just said that was 2.778. 2.778. Multiply it by the coefficient of your unknown, that's aluminum, 2, over the coefficient of your known, 3. So you multiply it by 2 over 3. This is going to give you the number of moles of your unknown. 2.778 times 2 equals, divided by 3 equals 1.852. That's the moles of your unknown. 1.852. And the reason I'm putting those asterisks there because you can see where the calculations came from, okay? Then you look at the last one. Now you've got your grams of your known was given. You calculated moles of your known. You calculated the moles of your unknown. Now you got to find the grams. All you got to do is find the molar mass of aluminum, Al equals, and you just have one of those, so it's 26.98, and you can multiply it by 1 if you want. You don't have to. So now you've got your, that's the molar mass of aluminum. So the last thing you have to do, let me go back to that last formula we did before. Copy and paste. So you take the moles of your unknown, which we've already calculated was 1.852, multiply it by the molar mass of that, which is 26.98. And that's all you have to do on this, times 26.98. That gives you 49.967. 49.967 grams of aluminum. There's your answer. Let me put this triple asterisk so you know what that one stands for too. Triple asterisk. Cut, let me copy rather, and paste it right there. There you go. So you need to finish the other ones. I did 2 for you. You have 8 to do today. So please take your time and get to know this stuff. I already told you that stoichiometry can be troublesome for a lot of kids and a lot of students rather. Do the best you can on these. I'm going to send your answers out just like I did today. I'll try to do those every day around noon or a little after, something like that. So y'all take care and stay safe. Okay, take care. Bye.